Okay, so we're going to look at the exam technique that follows a common type of question with the part A and a part B as follows. So to start with, we've got some kind of expansion, okay? So we've got an expansion up to and including x cubed, simplest form. This is pretty standard. So just to give you a rough idea, what you would do is you would rewrite it first. So you rewrite it maybe like this to start with. And then we need the first bit to be a 1. So what we would do, so we'd leave that 16 there. We'd factorize out the 4. It would leave us with this inside the brackets. Okay. And you'd effectively kind of like put the minus 1/2 on each. 4 to the minus 1/2 actually ends up giving you 1/2. So this bit here will end up giving you 8. And then you'll have the expansion, which is, the main part of the question, okay? So that's going to be doing this expansion, okay? We'd leave sort of the 8 until the end. We would list out our information. So I'm going to say this is the n value. I'm going to say that this is what's in the position of x in the expansion. Okay, we would then do our usual 1 plus nx plus n minus 1 over 2 x squared plus, and we'll have one more. We've gone over this in previous videos, so like I said, this isn't really the focus, but you'd end up getting 8 lots of 1. What would you have then? This will end up being minus 3x over 8 plus 27 over 128 x squared, and then finally minus 405 over 1024. And you'd make sure that you multiplied the 8 out to finish. Okay, so that's how you would do sort of your part A. And like I said, we've looked at that in previous videos. So to kind of jump us ahead, we're going to say that this is our expansion. Okay, that is that the expansion of this one here can be written as what's in here. So what am I interested in then? Well, I'm interested in today kind of what's happening when we go from here to here. Okay, so let's just change this one here. Okay, so what did we have in the previous question? Well, if I rewrite this, the 16 over 4 minus, okay, we're doing minus here, all right, 4 minus 3x to the half. Can you see that that's kind of still in there? And what's new then is it's this bit here. Okay, so this is kind of like our old sort of part of the question, our part A. And then we're going to multiply by 1 minus 2x squared. So this is the new part of the question. And the goal is going to be, we're going to try and find the coefficient of the x term that comes from when you have this old and this new situation. Okay, so I'm going to go back onto the next slide again. And I want us to have a think about what's going to happen when we do 1 minus 2x squared when we multiply it here. Now, notice if we did this whole expansion, there's a lot of stuff. We need to work out what this is first. And in fact, we can do that. That's not going to take that long. So let's just do that now. So let's do 1 minus 4x, you will get, plus 4x squared. So we'd have 1, 2, 3, 4 terms multiplied by another 3 terms. That's a lot of terms, but we're only interested in the x terms. So the question is, where does x come from? Okay, because not all of the multiplications are going to give you an x term. 8 times 1 is going to be in there, for example, but we're not actually interested in that. So where is it going to come from? Let's do this in a systematic way. Well, if I have on the old one, if I had the number times the x value, that would work, wouldn't it? Okay, so I'm going to do constant in the new one times sort of the x term. That will give me one of my places, but it might not be the only place. So where else could I get it from? Well, I could also do, couldn't I? Let's use a different color for this one. I could also do my x term in the first one times what? Times my constant in the next one. So this is effectively the other way around, isn't it? So x times the constant. And in some questions, there will even be 3 sort of multiplications that give you this. But for now, we're just talking about where determines x to the power of 1. Where does it come from? So we can work that out. That's not that hard. So the constant times the x means 8 times minus 4. So that's going to be minus 32. Okay? And how about the next one? Well, for the next one, we've got the x term times the constant, which is going to be just minus 3. So in this big expansion of all of this multiplied by all of this, we are only interested in these 2 parts. Okay, so the final value for the coefficient of x will be minus 32 plus this minus 3 is going to be minus 35. Okay, in other words, the final answer will have minus 35x. So it's quite common to sort of have some question where you do some sort of expansion for your part A, you get your answer here, and then, you know, this was meant to be a minus, okay? So then we're looking at this and we're saying, oh, I recognize all of that. What's this new bit here? So you have to think about the old bit. And remember, you've already got the answer for this. You already know what all of this is. And then they'll give you a relatively simple new piece. So this one wasn't too hard to expand out. Okay, and finally, the key question really is, if you're asked to find x, for example, where does the x part come from? If I had another question, for example, if it said, x squared, my question would be, where does the x squared come from? And it might be like constant times x squared. It might be x times x. It might be x squared times constant. Okay, so sometimes it can sort of come from 2 or even 3 different places, and you want to find out what those multiplications would be, and then finally add them all together.